So let's look. Some of this is review, but we're trying to put together a lot of different tools that we have in order to factor. Let's look at the first example here. This one we saw when we did quadratics. When did we do quadratics? Last semester. You guys have this, okay? Our method for this was always to look for two numbers with certain properties. They multiply to give you what? Negative 20, and they add to give you negative 1. What numbers possess those properties? Yeah, so 4 and negative 5. Always double check. You multiply those numbers, you get negative 20. You add those numbers, you get negative 1. That means I can take these numbers and factor this one. How? This is where you would participate with the teacher and you would say, take these numbers and how do I factor this? Yeah. X what? Plus 4. X minus 5. That is the factorization of that polynomial. How could you check and make sure you got that right? You could FOIL this, multiply it out, you would get the right answer. This one was a little bit different. What was different about this one? What's different about the way we factor this one? Yeah, so over here, similar, but I'm going to need two numbers that multiply to give me what? Negative 12 and add to give me negative 1. What numbers will do that for me? Yeah, negative 4, positive 3. Those multiply to negative 12, they add to negative 1. But now, what's my next step? This is probably the biggest difference, the way we factor this one. What do I do next? Yeah, 6x squared minus 4x plus 3x, because I'm going to have to factor this by grouping. That means I'm going to look at the first two terms and the second two terms. What do the first two terms have in common? Yeah, 2x, and I'm left with 3x minus 2 plus 3x minus 2. Now both of these terms have what in them? 3x minus 2. What's the final answer here is what? 2x plus 1, 3x minus 2. Okay, this is stuff that you knew last semester. We're just trying to resurrect it, and hopefully we did not have to dig too deeply to find that body of knowledge. Okay? Now, other things that we've got to be very comfortable with is factoring is just, it's a toolbox. It's a bag of tricks. Okay? You got to figure out what all things are at your fingertips. Okay? One of the things you need to make sure that you can do is factor out the greatest common factor. We did that in grouping, but when I'm presented with something like this, okay, I haven't taught you methods for factoring cubics yet, but if I look at that, what do these three terms all have in common? Yeah, factor out the greatest common factor, which is 2x, okay? What do I multiply 2x by to get 2x cubed? X squared. What do I multiply 2x by to get negative 2x squared? Negative x. What do I multiply 2x by to get negative 40x? Negative 20. Now, what you see outside the parentheses is 2x. What do we see in the inside the parentheses? This is a what? What is that? That is a what? Starts with a Q. It's a quadratic trinomial, okay? How long ago did we factor this? Yeah, we factored that a few moments ago, right? We factored this as x plus 4, x minus 5. So this is 2x, x plus 4, x minus 5. So I had to use two different techniques. I had to factor out the greatest common factor, and then that gave me a quadratic, and then I had to figure out I know how to factor quadratics. That's going to be a theme throughout this unit is get it down to something that's a quadratic. We're going to have different methods for it, then factor the quadratic. Okay? Now, there are a few other things that you want to make sure you can recognize and factor. One is factoring the difference of two squares. Okay? This one, there's no guesswork. There's no multiplying numbers, adding numbers, and grouping. There is a formula. It is up to you to memorize and recognize this formula. When you see two things subtracted, that's where the word difference comes. Difference of two squares. A squared minus b squared is a minus b, a plus b. So, for example, if I had x squared minus 9, according to this formula, that will factor how? x minus 3, x plus 3, okay? If I check it, when I multiply this, I get x squared minus 3x plus 3x. The x's go away, minus 9. Okay, so anytime you see two things that are perfect squares and they're subtracted, then you can factor that. So when I look at this, these are both perfect squares. So 16x to the fourth, what's the square root of that? 4 what? X squared. So this is 4x squared minus 1 times what? 4x squared plus 1. Okay? Now look at this thing that's subtracted. Are those perfect squares? Right here. Yes? What's the square root of that? 2x minus 1, 2x plus 1. And I don't have a formula for the sum of two squares. So that's just this. That's the complete factorization. So when you come to difference of squares, every time you see a subtraction and it's a perfect square, you have to say, well, I can factor that, okay? So again, the square root of 16x to the fourth was 4x squared. So this is 4x squared minus 1, 4x squared plus 1. Square root of this is 2x. So 2x minus 1, 2x plus 1. That's the complete factorization for that one. So with difference of squares, you got to be able to look at it, recognize it, apply the formula, and maybe look at it again, recognize it again. It may happen repetitively. So for example, if I had, x to the fourth minus 81, that's the difference of two squares. This is what? X squared what? Minus 9, and then x squared plus 9. This is the difference of two squares. What is this one? That's x minus 3, x plus 3 times x squared plus 9. Okay, so sometimes with difference of squares, you'll factor it, and then you have to factor it again. The only method we learn when you see four things and they factor is factor by grouping. So in this case, you factor the first two terms, the second two terms. What do the first two terms have in common? X squared. So if I factor out an x squared, what do I multiply x squared by to get 2x cubed? 2x, okay, plus 1, and then bring down this minus sign. What can I factor out of the next ones? 4. What do I multiply negative 4 by to get a negative 8x? 2x, okay. What do I multiply negative 4 by to get negative 4? Okay, and then this becomes what? X squared minus 4, 2x plus 1. Is that completely factored? No, x squared minus 4 can be factored as what? Yeah, x minus 2, x plus 2, and 2x plus 1. So that is the complete factorization. So we started out with a cubic. I didn't have methods for factoring cubics, but I knew factor by grouping, and then that brought me to difference of two squares. Okay, you've seen difference of two squares before, right? This is yes, okay. Now, what you may not have seen before, difference of two cubes, sum of two cubes. If I were an Algebra 2 student in 10th grade at Woodward Academy in February of 2019, I would write something like, I need to memorize this. I would make myself a note to say that this is very important. This will be on your quiz. This will be on your test, okay? We have a formula for the difference of two cubes. You have to know the formula and know how to apply it. So a cubed minus b cubed is just a minus b times a squared plus ab plus b squared. A cubed plus b cubed, a plus b, a squared minus ab plus b squared. Okay, an easy way to memorize this is there's an acronym when you are smelly after you work out, you need soap to clean yourself, so just remember the word soap. This is the same sign as this, okay? This is the opposite sign of this. This is always positive, okay? Same thing here. This is the same sign as what you have here. This is the opposite sign of what you have here. This is always positive, okay? So if you can just remember, I've got cubes, a cube, b cube. Put an a and a b here and give it the same sign as whatever that is. Square that, it goes here. Multiply that, it goes here. Square that, and it goes here. This is the opposite sign of what you see here. This one is always positive, okay? So you got to figure out a way to memorize this and look at it and apply it when it occurs in the wild here, okay? So for example, if I had x cubed minus 27, those are perfect cubes, right? According to this formula, I'm going to have x minus what? X minus 3, okay? And then I'm going to look at it, okay, then I need an x squared, I need a 3x, and a 9. So I square this, I multiply these, and I square that. This is the same sign as this. This one is the what? Opposite sign. That one is always positive, okay? If I had x cubed plus 8, that's going to be x plus 2, and then x squared, 2x, and 4. This is the same sign, this is the opposite sign, and that one is always positive, okay? So find a way to know this, memorize this, and recognize it when you see difference or sum of cubes. Last year's group, when that showed up on the test, they treated it like a trick question, okay? It's not a trick question. You'll need to know that method, okay? So let's factor this. Let's talk about the methods we use. So look at this one. The first thing you want to always do is if there is a greatest common factor, take that out. That will simplify things. Is there a greatest common factor here? Y. Okay, we'll disregard that 4. What do I multiply y by to get y cubed? Y squared. What do I multiply y by to get minus 4y squared? 4y. And then what goes here is a 3. Now, what do I have inside the parentheses? That is a what? Starts with a Q. It's a quadratic. Okay. Oh, sorry. You guys don't get upset. Just say like, oh, it's a mistake, you know. Y squared minus 4y minus 12. That's a quadratic. That part doesn't change. I solved this without fear by looking for two numbers that multiply to give me what? Negative 12. Add to give me negative 4. What numbers are possessing of those properties? Negative 6 and positive 2. Those numbers multiply to negative 12. They add to negative 4. What do I do with these numbers? I just go straight to my answer. There we go. That's it, okay? So this would have been a really good problem for last semester, factor quadratic. All I did was multiply the whole thing by y, and you had to go one step further. You had to factor out a greatest common factor. Then you're into last semester's problem, okay? So factoring, this toolbox, this bag of tricks, you know, you got to figure out what works to break these things down into something you have a method for. Look at the next one, okay? Do they have anything in common? Yeah, they can factor out a 3x, so that leaves me with, what is it, x squared plus 10x plus 25. So what's in the parentheses is a quadratic. Yeah, and I will look for two numbers that multiply to 25 and add to give me a 10. Those numbers are what? Yeah, 5 and 5, okay? So that means you can write this as 3x, x plus 5 times x plus 5. You would be just as correct if you wrote 3x and x plus 5 squared. Either of those is a correct answer for this, okay? What about the next one, okay? Do they have anything in common? 5g what? Cubed. Okay, so 5g cubed. What do I multiply 5g cubed to get 5g to the 5th? G squared, okay. What do I multiply 5g cubed by to get a negative 80g cubed? Now, what do you have inside the parentheses? That is what? Difference of two squares. So this is 5g cubed times what? Yeah, g minus 4, g plus 4. It doesn't matter which order you put those in. Okay, that's the final factorization of this. So I had to use two methods: greatest common factor, difference of cubes. Okay, you just got to be comfortable with all these methods when they apply. In the pecking order, if you can factor out the greatest common factor, that will always simplify into something that's easier to factor. Okay, let's look at the next one. What's our strategy for this one? You cannot factor out a 3 because 125 is not divisible by 3. This is the difference of two what? Cubes. Okay, there was a formula on the previous page that your teacher said you were responsible for memorizing. Okay, I know you haven't memorized yet, but a cubed plus b cubed. That is a squared, ab, and b squared. This first sign is the same sign as what this is. That's the opposite sign, and that one is always positive. So that's my formula. So to factor a cubed plus b cubed, figure out what the cube root of this is, the cube root of that. So what is the cube root of 27x cubed? 3x. Okay. What is the cube root of 125? 5. Okay. So that's this a plus b. Now I square this. What happens when I square 3x? 9x squared. What happens when I multiply the 3x and the 5? Yeah, 15x. Remember, that's an opposite sign. And when I square that, 25. Okay. So again, there's not a lot of work here. You can see how, if you didn't know this formula, how hard would this problem be? It is very hard. Okay. So it's substituting into the formula. Okay. It's knowing this formula, sum of two cubes, knowing how to apply that formula. Okay. So you're going to have to spend time to make sure you can work with that. Look at the next one. What is my immediate way of first attacking this? I want to do what? Factor out what's in common. What's in common? 2 what? D squared. Okay, so let's factor 2d squared. What do I multiply 2d squared by to get a negative 2d to the 5th? Negative d cubed. Okay. What do I multiply 2d squared by to get 250d squared? 125. Okay, so I've factored out the 2d squared. What do I have left inside that parentheses? Perfect cubes. Sum or difference? Huh? Yeah, I would write it like this. It is the difference of two cubes, okay? If you called it the sum of two cubes, then you're going to have negatives in here because the cube root of this is negative d. So you're going to deal with that formula with negative signs in it. Just write it as either a cubed plus b cubed or a cubed minus b cubed. So this is better done as the difference of two cubes. And that formula, a cubed minus b cubed, is a minus b, same sign, opposite sign, always positive, okay? That's my formula, okay? So I need to, when I factor this out, it's 2d squared. So what goes into this a minus b? That's going to be what? 5 minus d, okay? And then I square that and I get a 25. 5d and d squared. That is the same sign, so that's a negative. That's the opposite sign, and that is always positive. Okay, so you can leave it like this, or you can, we would tend to write it more like this: 5 minus d, d squared plus 5d plus 25. The other thing, this quadratic, you notice me not trying to, what if I factor this? What are two numbers that multiply to 25 and add to 5? What are the factors of 25? 5 and 5, and 1 and 25. Can you add those and get a 5? No, this does not factor, okay? So, which one? I just switched this. We normally see this as d squared d in the constant term, okay? Yes? Well, the cube root of 125 is 5. Cube root of d cubed is d. So this is 5 minus d. Okay, so this formula, I think it's new. You have to memorize it and know how to use it, okay? So we'll use it again. What do you see here? This is not factor by grouping. It's not a quadratic. They don't have anything in common, but this is the difference of two what? Perfect what? Cubes. So you have a formula, a cubed minus b cubed. I would encourage you, write this formula down, as you work these problems so that it becomes part of your muscle memory. So that is my formula, okay? So what's the cube root of 27x cubed? 3x, okay? What's the cube root of 8y to the 6? 2y what? 2y squared. When you cube that, you get what? 8y to the 6, okay? Now, what happens when you square that first term there? What is this? 9x squared, okay? And then the opposite sign, what happens when you multiply this times this? 6x y squared. And then what happens when you square this? 4 what? 4y to the 4th. I heard 4y cubed, which didn't sound too good. When you square the 2y squared, it's 4y to the 4th. And that's it. So, I mean, this looks complicated, okay? But all it is recognizing this is the difference of two cubes and writing that using our factoring for difference of two cubes. You can, right, so the formula is take the cube roots to get this first term, keep the sign the same, and then once you've got this, you square this to get this, multiply that to get this, square that to get this, and your signs are always same, opposite, always positive, okay? If you had this formula in Microsoft Word, this would be just as hard as search and replace. Everywhere you see an A, put a 3x. Everywhere you see a B, put a 2y squared. So Microsoft Word with search and replace could solve this. I'm oversimplifying that, but it's know the formula, and then all you're doing is just substituting into the formula, okay? So let's do a few examples of things. What's our attack on this one next? Grouping. The only method you have for 4 terms at this point is grouping if there's nothing that they have in common, okay? What do those first 2 terms have in common? Is the 3 the highest thing they have in common? 9. So this is 9t, and then I'm left with what? 3t plus 5. And then minus whatever this sign is that you see right here, bring it down, okay? So this is what? 3t plus 5. Remember, this minus 3t minus 5. That distributes across there. Now you see a 3t plus 5 in both places. This is 9t minus 1 times 3t plus 5. What about the next one? Yeah, grouping. It's 4 terms. They're no greatest common factor. Look at the first. 3 what? Um, 3t plus 1, 3t minus. Okay, yeah. There's not a difference of squares. So this one, 4 terms, no greatest common factor. The only thing you have is grouping. What do the first 2 terms have in common? 2x squared. And then I'm left with what? 3x minus 2 plus 3x minus 2. Now what do they have in common? 3x minus 2. So this is what? 2x squared plus 1 times 3x minus 2. Okay, so grouping was all I needed to get this one factored. I feel like I have skipped over some problems, have I? Or else it's just going quicker than it did with the other kids. Okay. Oh, I think I do one more method and then I have some that are mixed together. Okay, yeah, we'll do this. So there's one other method that we need to talk about. It's not radically different, but it's just sort of a different mind shift of things. Let's look at these 2 things that you see here, problem on the left, problem on the right. What do these problems have in common? Yeah, the coefficients are the same, okay? I've got a 1, a 2, and a negative 3. The one on the left is a quadratic equation because it's x to the 2nd power. The one on the right, it's not a quadratic, but it's very similar to the quadratic on the left. So what we will say is this one is in quadratic form. So we have a way of solving it that is similar to a quadratic. So to solve this one, I would look for 2 numbers that multiply to what? Negative 3 and add to 2. Those numbers are what? Positive 3 and negative 1. So that means this is what? X plus 3, x minus 1. Okay. So in this problem here on the right, so I'm going to do it this way, but then we probably won't do it after this. What if I were to say, let's let z equal x squared. Okay, I want to make a substitution. Let z equal x squared. Okay, I want to rewrite this equation in terms of z. Okay, so if I rewrite this, instead of x to the 4th, I'm going to write z to what power? Z squared plus 2 times what? Z minus 3. Okay, now what is that equation? It's the same equation you see over here. So this is what? Z plus 3 times z minus 1. That's a quadratic equation. But remember, z is equal to what? Yeah, z is equal to x squared. So this is really x squared plus 3 times x squared minus 1. Is that completely factored? No, one of those can be factored again. Yeah, this is x squared plus 3, x minus 1, x plus 1. Okay. So this was solved by, I did substitution. I think you're going to get by without doing this. This adds a little bit of complexity to it. But what I wanted you to see was, if I made this substitution, this became a quadratic equation in the variable z. Okay, so I solved it just like any quadratic with the variable being z instead of x. And then I substituted x squared back in for z, and I was able to get my final factorization. Okay, now you don't have to go through this every time. We'll take a few shortcuts, but what you really need to be comfortable recognizing is when a polynomial is in quadratic form. Okay, so you know what it looks like to be a quadratic. It has a squared term, an x term, and a constant. That's a quadratic. It is in quadratic form if it looks like this. You've got ax to some variable and then bx to half of that same exponent. Okay, so for example, if I have x to the 6 plus x cubed plus 3, that is quadratic form. Okay, because whatever this is, this exponent is half of that. if I had x to the 10th minus x to the 5th plus 7, that is quadratic form because I've got this variable and then half of that, okay? So what it means when it's in quadratic form, I can solve it just like I do a quadratic. So let's take a look at the next one here. This one, what is my first strategy for this one? Do they have anything in common? 3y squared, okay? What do I multiply 3y squared to get 3y to the 12th? Y to the what? 10th, okay? What do I multiply 3y squared to get 54 y to the 7? 3 times 14 is 42. 18. So it's 18. And then the y squared. What do you multiply y squared to get a y to the 7th? Y to the 5th. Plus, what do you multiply 3y squared to get 51 y squared? 17. Now, what you need to be able to recognize is what's in the parentheses is not a quadratic, but it is quadratic what? Quadratic form. Okay, so the methods I use to solve this are the same as I use for methods for quadratics. So I'm going to look in the parentheses. I need to find two numbers with the magical properties that they multiply to give me what? 17, and they add to give me 18. What numbers can multiply to 17 and add to 18? 1 and 17. Okay? So that is my key for factoring what is in the parentheses. So I'm going to have 3y squared, and here's where it's different. Okay? It's not y plus 1, y plus 17. This is y to what power? So it's y to the 5th plus 1, y to the 5th plus 17. That's the factorization of this one, okay? So I didn't do this substitution. I could have said let z equal y to the 5th. Then this would be y squared plus 8, excuse me. If z is y to the 5th, this would be z squared plus 18z plus 17, then go back and substitute. Once you recognize quadratic form, whatever this is, that's going to be your factorization. So I find the two numbers. It's y to the 5th plus 1, y to the 5th plus 17. Does everyone see that? Okay. So again, you want to be comfortable. It looks complicated when you see y to the 10th and y to the 5th. You think, I don't know how to factor that. Recognize its quadratic form. Factor it like you would any quadratic. Let's look at the next one. Okay, this is not a quadratic, but it's quadratic what? Quadratic form. You've got an x to the 4th and an x squared. So factor it like you would any quadratic. Two numbers that multiply to what? Yeah, negative 15 and add to negative 2. Those numbers are what? Yeah, negative 5, positive 3. Negative 5 and positive 3. Those are my numbers for factorization. So I just look at, this is what, x squared. So my factorization is going to be x squared minus 5, and then what? X squared plus 3. And that's the complete factorization. What if this had been an x squared minus 9? What would you do? Then it was x minus 3x plus 3. You could go factoring a little bit deeper, okay? So, guys, this was probably the longest lesson we're going to have leading up to this quiz. It's probably the most important because factoring, we don't do it just to torture you. We use factoring because factoring is a method we use to solve. Tomorrow we start solving equations. So you need to be solid. The methods we talked about were quadratics. We did that last semester. Greatest common factor. What do they all have in common? Factor by grouping. Then we did difference of two squares. The one that was new for you was the sum and difference of what? Two what? Cubes, okay? There is no shortcut to you memorizing that formula and being able to recognize it. And then the other thing that was new was when something is in quadratic form, be able to recognize that and factor it like you would any quadratic. Okay?